So it's a little database, sort of easy with it, just one place. Yeah, it gives me a bit more practice doing things. Yeah. Well, because it's very case, we actually see it because I've got a link to it. That's what I said, I like doing it, because trying to do it without fear. Yeah. So I don't think that's all I'm going to do. I can get one on the so-called manufacturing. I just want to know if they're good. Yeah. Some people that say, which way will be some of the tree. The secretary, and she had his hands. Two hours long, just with those, and she got pretty good. Overload. This is very good for the secretary. She's not going to trade it. And she made up the full the other side of the years. The trouble is, everyone else is not. Yeah, well, that's what I like about those Myers-Briggs tests. Whole series of tests. And then basically there's no the thing that people aren't really about probability is actually time. Not so much time, but they give you more than enough time to talk. It's random, so B, C, D, A, C, B, B, C, B, A, C, D, all the way through. That's just random, just randomly make it as quickly as it can. So in most cases, when you do that, you'll be exactly what you're going to do. So that's a correct test. So you do it. That's right. Because I've never seen the results. Oh yeah, I'm going to build clusters. I have one ready to go. I'm thinking of doing a cluster with no proximal. So that thing I just showed you. So I need to get three.
It's on now. Can you hear me?
And then just get the right.
It's on now.
Long standoffs and then stack them. Cool.
Sorry. My cable must be a bit dodgy. I don't put so much weight on the thing. I could do it. Do that. Right. Hello and welcome to this one SLUG. Sorry about the late notice in there. Is this a bit loud?
That's fine. That's not.
Okay, sounds very loud here.
Oh.
Turn it. Okay, so how does that sound? For now. Just talk. Talking 1, 2, 3.
Yeah, that's good.
Yeah. As I was saying, sorry about the late notice. It was kind of a last-minute talk. I'm Robert. I'll be talking to this today about virtualization. Just basically an overview of all the different tools available and what they're optimized for and whatnot. So I'm gathering from some of the conversations that went on here that a few of you have played around with virtualization. So some of the lower level stuff might be a little bit more basic for you, but we'll start. So there are a number of different types of virtualizations. You have containers, which are basically what Solaris used to call zones, and these days Docker is very popular as well. Basically, it's just the one OS that has a sectioned off area for the processes, so basically process isolation. This can be as small as a single process or as broad as a whole OS within the a whole OS, but still has to have the Linux kernel in common, or the kernel in common. Then you have emulation, which is slow but still used for specialized purposes. Type 1 virtualization is basically where you try to get everything to run on the CPU, but because CPUs have different run levels or different rings, you have to actually change the machine code as it comes in. So anything that's going to try to run on ring 0 has to be massaged to not run on ring 0, because only the core host OS can run on ring 0. So that's what that's what VM used to use before CPUs started doing specialized hardware to do that sort of thing. And all the modern ones use, such as KVM and that sort of thing, use the modern CPU features, which are featured in Intel processors and whatnot. Parallel virtualization is a little bit halfway between a little bit. So basically, parallel virtualization is either where you modify the operating system, so as it runs, it knows that it's running on a virtual machine, that it's running in a virtual machine, or you tweak the drivers and some of the other bits and pieces. So you'll find that VMware has its own display graphics driver, so it doesn't have to do any of the graphical initialization stuff that a hardware graphics card needs, because it's a virtual graphics card. It doesn't need that much work, so it can take a lot of shortcuts and speed things up. These days, in Linux world, a lot of them are using Virtual.io, which was a Red Hat tool, and they virtualize the hard disk drivers and the network drivers, as well as the graphical drivers. So they're a lot faster, basically. So there are other components, of course. A lot of these components are in common with a lot of different virtualization tools. So you've got your virtual hard disk. VMDK is VMware's virtual hard disk. VHD is VirtualBox. And with Linux, the QEMU image tools, which most of the Linux KVM and virtualization tools use, can pretty much read and write to any of them. So QCOW is the native QEMU image, but it can also use RAW or VMware's virtual hard disk and that sort of thing. There's a number of features in virtualizing hard disk. First of all, you can make the image sparse. So what that means is that if your virtual hard disk is 10 gig, but you've only filled up 3 gig of it, then you want the only 3 gig used up on your real physical hard disk, rather than taking up 10 gig regardless of how much of the virtual hard disk you're actually using. So that can happen at 2 different levels. A lot of file systems support sparse files. So even just a normal file that has a blank area in it will just not take up that room on the hard disk. but the QEMU image formats do support sparse images as well. So even if the file system doesn't support it, it can be supported at the QEMU image level. Of course, you've got the basic snapshots, which pretty much every virtualization tool uses these days. The snapshot can store CPU and memory configuration as well, but it doesn't have to. Another option besides snapshot is backing files. So with QEMU image tools, you can actually have your original Windows disk, and you can say, I'm going to make this image based off that Windows disk, and that image will only store what differences what you write to the disk. So this is your read-only disk. It never changes. It's static, and whatever it gets written to this. And what the virtual machine sees is a merging of both those. So you could install Windows, and you can have your install your software and all that sort of thing, make that your base image, and then your actual writing image is only a small, and anything that gets only contains what gets updated on that hard disk. Then you could have effectively multiple images based off that same file. So you could have your one disk that has the Windows and all the software, and you could have a dozen different virtual machines running off that effectively anything they write gets written to that separate file, but they use the same 10 gig Windows disk. With networking, you've got so network is basically the way to connect to other guests and the other hosts out there. So there's a number of different ways you can do that. So the traditional way is with a bridge. VMware does this pretty much automatically, but in Linux virtualization, it's always been a bit of a pain. These days, they also have Mac VTAP, which is basically, I'm not sure how that's meant to be pronounced, but that's what I would pronounce it as. It's basically doing the same thing, but it's doing it at a different level. The main disadvantage of the Mac TAP is that you can't talk to the host that way. It doesn't enable you to loop back to the host. So as long as you're not trying to connect between the host's machine and the guests, then you could use MacV. Otherwise, you're going to have to use Bridge or some other method. The other way to do it, of course, is with traditional NAT and routes. So in that case, you would have your virtual network device, or basically a TAP device in your Linux host, and all the virtual machines would connect to that. And your host machine will just see that as another Ethernet port to which you can route IPs and go through a NAT to out to the real world, or go through, set up a IP route or whatever it is. A lot of the bigger boys these days are very much into virtual switches. It's this whole fad at the moment to do software-defined networking and things like that. I can see the advantage of it in a lot of situations, especially when you've got limited IPv4 address space. I find it more complicated than it needs to be, but I'm not generally dealing with big virtualization servers, so maybe I would feel differently if I was. So the Linux fundamentals. So a lot of the Linux virtualization started with QEMU. So QEMU is just an emulator. It pretty much can emulate any processor on any other processor. So if you are developing for an ARM-based tool on an x86 machine, you can actually run ARM-based code within the QEMU emulator. It was also used to emulate x86 on x86 machines, but because it was actually emulating the processor, it's basically a very slow way of doing things. So then it came along KVM. So KVM built into the Linux kernel methods for which you can take advantage of the newer processor's extra feature set. So Intel and AMD added specific features into their CPUs that allowed for virtualization, and KVM basically utilized that to set up a virtualized machine. There was a tool for QEMU that did the older style where it did the whole, the type 1 hypervisor where it had to translate on the fly and all that sort of thing. But it's sort of, everybody these days has CPU that has the special features, so you don't really need it. And of course, there's others out there, Zen, VMware, VirtualBox. Most of these are not built specifically for Linux, but they do run on Linux. Some of them don't even require specialized modern CPU features, as I was saying, because VMware's been around before those features even became available in CPUs. So there are useful tools that can be used on a lot of different virtualizations. The big one that you'd probably, these are mainly command line tools. So QEMU image is a tool that you can use to create images or view the image and whatnot. So you can resize, manipulate them basically. GuestFS is basically a collection of tools for mounting a virtual hard disk on your physical machine. So you could mount it and then go into it like a normal mounted drive and see what's in there. There's a whole bunch of tools that seem to all start with virt-something or other. Some of them that I've used the virt V2V before. It basically converts a hard disk image from one style of virtualization to another. So when I used it, I took a VMware hard disk image and converted it to a KVM hard disk image. And it actually goes inside, because Windows doesn't handle changing hardware too well. It's not dynamic like Linux is. And if you just take a VMware Windows image and try to run it on a KVM virtual machine, Windows will just go, I don't recognize this hardware, and they'll have a fit about it. So the V2V will actually change the drivers within Windows such that it will then run. I think it even goes so far as to add the virt.io guest tools into it. But at the very least, it converts the hardware so you can run the Windows image on KVM. Change it from a VMware image to a KVM image. There's also a P2V, which does a similar sort of thing, but for physical images. So if you've got a physical machine, you can take a copy of the hard disk and do the same thing. Forgotten what the convert was. There's other tools in the virt collection. Sparsify will free up blank space in the hard disk. So in a virtual machine, if you go install software, it's obviously used up more hard disk space. You then delete that software. The operating system is aware that you've deleted those files. But at the virtual hard disk level, at the virtualization level, you can't know that because it's not viewing that file system. It's not interacting with that file system. Sometimes it may not even know what that file system is, but it can't know what has been removed and what hasn't. So your virtual hard disk tend to bloat over time. And even if you delete files and clean up the trash and all that sort of thing, it doesn't just automatically shrink the virtual hard disk. So the Sparsify is to basically shrink the virtual hard disk back down to what's actually being used. There are other tools such as ls, edit, tar, rescue. These are basically also to manipulate the guest image. So ls, of course, you can list files that are in the guest image. Edit, you can actually edit a file in the guest image. Tar, you can upload a file to the guest image or download a file from the guest image. And rescue is basically like a rescue CD without having to have an ISO image of a rescue distribution or something like that. And then of course, you've got the more external tools such as Spice and VNC. Most of Linux virtualization uses VNC to view the console. So when you're running your virtual machine, the virtual machine is writing to a graphical card. It's actually just a virtual graphical card. And all that information on that virtual graphical card is available to you on a VNC view of that console. Spice is basically just a newer version of that adds certain features. So now we're getting to more of the actual virtualization tools. You can run things in raw KVM, but it tends to be quite wordy and quite technical. These tools are more for automating it and for other applications to use to interact with your virtual machine. So libvirt's the big name in the industry. It pretty much, most apps that do virtualization seem to use libvirt to some degree or another. Basically, it talks to KVM, it can talk to Xen, it can talk to VMware, and basically it's just an application library for interacting with virtual machines. So if you write an application that uses libvirt, you can pretty much use any virtualization tool at the base level. So most of the tools use that. Virshell is basically command line interaction with libvirt. So you can actually log into, type in the command virshell, press enter, and you can type help and see all the commands. But you don't have to go into the shell to do that. You can actually, from the command, just type virshell, start image, virshell, create image, whatever it is you wanted to do. And that works just fine too. So it can be used with scripts or with just command line. It's really up to you. A lot of the virtual stuff seems to come down to editing the actual XML. The XML being part of the libvirt set configuration of the virtualization. Vagrant is another tool that started off being part of VirtualBox. Solaris make not Solaris anymore, are they? Oracle make VirtualBox. So Vagrant was a tool that was designed to work with that virtualization platform, and it allows you to actually automate the whole creation and running of a virtual machine. So Vagrant will actually allow you to get into the virtual machine and run commands inside the virtual machine. So it's used very heavily for things such as automated testing and things like that. You can script basically the creation, starting, get in and install software on a virtual machine, all that sort of thing. The first Docker tools that were running on Windows were actually using Vagrant to start up a virtual machine, run Docker in the virtual machine, and connect you to that Docker image, rather than, because Windows didn't support Docker at the time. It still doesn't fully support Docker, but it's coming. All right, so now we've got the basic applications. So Virt Manager is the one that's been around for a long time. It basically allows you to create the virtual machine. Again, it uses libvirt to talk to the virtual machine at the back end. It can talk to the virtual machines either on the local machine or remote. GNOME Boxes is another tool that obviously released by GNOME. Again, it uses libvirt, but it's more designed for home use and basic sort of level of stuff. Virt Manager allows you to get into much more detail. GNOME Boxes is meant to just, I just want to run a virtual machine. I don't care how it runs or anything like that. I have tried Web Virt Manager, which worked okay, but then sort of didn't really, I had issues with it. And then I tried something and I broke the Docker image that I had created to run it. So I think the big advantage with Web Virt Manager was that you could actually edit the XML directly, So Web Virt Manager doesn't offer as many features as Virt Manager, but because you could get in and not actually edit the XML, you could still do pretty much anything that you wanted to do. But most of it, you had to really get into the XML if you wanted to do something complicated. Still be good enough to start a virtual machine and give a couple of people access to it and all that sort of thing. Kimchi is another one. I think that was actually part of IBM's portfolio. Again, it's both Web Virt Manager and Kimchi are both web-based, HTML-based. That will actually display the console to you in a HTML5 rendered canvas. So you don't need any special tools. You can actually get in and run the console, connect to the console, see the whole virtual machine, all that sort of thing, without having to have VNC or anything like that. They basically take VNC, they connect via VNC and map that across to a HTML5 canvas so you can view it from wherever you are. Again, with Kimchi, I had trouble installing it and getting it to run properly. It does look like a very much simpler tool than Web Virt Manager. It looks a lot prettier. And it has this neat little feature with templates where if I have a disk image and I make a template off that disk image, when I make a virtual machine from that template, it doesn't copy the whole disk image. It just makes a new image that's based off that first image. So it makes the creation of a virtual machine very quick and very efficient in terms of space and that sort of thing. So you'd have your virtual hard disk installed with Windows and all this sort of thing. You make that part of the template, and then when you spawn a virtual machine from that template, the additional space you take up is maybe a meg or two, a couple of meg or whatever, and then whatever you write to that virtual hard disk would then make that more. But it would also mean that you could start off a dozen virtual machines from that one template. They'd all be based off that one Windows image and only store the differences for themselves. There's a number of tools that are specifically for interoperating between clusters, between virtualization types and virtualization clusters and whatnot. Eucalyptus, I know Ubuntu has been pushing Eucalyptus quite a lot. It doesn't see, a lot of these tools don't seem to have much in the way of a graphical interface. They're more for scripting. Excuse me. But it would make it possible, for example, to have a single management platform that could potentially start the virtual machine on either your own internal stuff or an Amazon EC2 instance or a Windows Microsoft Azure instance, and you could move the machines between those instances as you pleased. So you could potentially have your own cluster where you have all your virtual machines running, and if you find yourself under heavy load, you can then start to farm those virtual machines off to Amazon EC2 or whatever it is you choose to use. So like I was saying, Eucalyptus is mainly CLI based, command line based. Nimbus seems to do the reverse. It seems to make, I haven't played with much, any of these tools, so I'm just mainly going off what I found on the web. But Nimbus seems to add functionality to your virtual machine such that your virtual machine can behave like an EC2 instance. So that way you could have the same code controlling the virtual machine regardless of whether it was an actual Amazon EC2 instance or a virtual machine that had Nimbus installed on it. OpenNebula seems to do a similar sort of thing, controlling multiple clouds. It seems to be able to go both ways. So again, you have an API that looks very much like Amazon EC2, so you can use the same tools that you use to control your virtual machines in Amazon to control your virtual machines in your own cluster. but it also able to do the other direction, whereby you have your virtual machines in your own cluster, but then you decide to move that virtual machine to the cloud, to Amazon EC2 instance or whatever. OpenQRM, I couldn't really get too much on that.
So, why is eucalyptus called eucalyptus?
I have no idea. I've heard Ubuntu pushing it, talking about it all the time and that sort of thing. I didn't see that much of it. But I'm really looking for a GUI type, a web type interface, and it doesn't really seem to do that. Sorry, yeah?
I'm just curious, maybe a stupid question, but does OpenStack fit on any on these?
I'm covering OpenStack a little further. So now you get to more the bigger applications. This is getting more away from, this is not something you would do in even a small office, because it gets much more complicated. So Red Hat have a virtualization platform. They call it Red Hat Enterprise Virtualization. And it's based off the Overt tool. They bought some company and open sourced it and do what Red Hat normally does. So Red Hat Enterprise Virtualization is pretty much just Overt, all packaged up for you and under the Red Hat support contracts, etc. Overt is basically to manage your own private cluster. There's different concepts for virtualization. You can scale up or you can scale out. So by scale up, they mean that you've got a virtual machine that you want to put on a bigger virtual machine, bigger host machine, or make bigger, give it more memory, all that sort of thing. Maybe even have it fail over to another physical host, but that virtual machine is important to you. You want to maintain that virtual machine. Scale out is the other scenario where you don't care about your virtual machine. If it breaks, you throw it away and make another one. So the whole notion of either a virtual machine being a pet or being cattle. In the case of scale out, it's cattle. If it dies, you spin up another one, you kill it off, you don't bother trying to fix it. If it's a pet, it's a scale up type scenario. You maintain the virtual machine. If it breaks, you fix it rather than throw it away and start again, that sort of thing. It's basically different ways of thinking of your software. Obviously, if you're doing a scale out type scenario, your application would probably want to be more robust in recovering this sort of stuff, because if you're going to be throwing away your virtual machines, then obviously the data has to be stored in a central location. It has to be aware that, I'm not the same machine as I was yesterday, but, and cope with all that sort of stuff. So there are two major components for Overt. You have the engine and the node. The engine is the management platform, and the node is basically any any physical host that you're running the virtualized machine on. So it's not designed to run on a single machine. It's designed to run on a group of machines. You might have one engine, or one or two if you want redundancy, and you might have a dozen physical hosts, and your virtual machines are distributed across all those. It does talk about automating the installation of a node. So if you point it to a physical machine and say, this is going to be my node, it will try to install everything it needs to make that a node and do it. There's also distributions that are specifically designed to be a node, so you don't have any of the overhead of other stuff on there. Overt also has API and script hooks, so you can actually make it so as every time you start a virtual machine, every time you create a virtual machine, it will run scripts, whatever script you decide it should run, and that script will influence the creation of that virtual machine. So you can automate a lot of your creation of this sort of thing. Likewise, APIs, so other software applications can talk to Overt and tell Overt to create a machine, delete a machine, move a machine, whatever it has to be. They also talk about Nagios monitoring being built into it, and reports, nice pretty graphs of how many virtual machines and which machines it's running on, how often it fails, all that sort of stuff. So CloudStack seems to be the one that I want to try next. I haven't really, only learned about it recently, so I didn't really get a chance to try it. It seems to be a single application that does, the whole graphical interface and management of your virtual machines and that sort of thing. It still seems to be aimed at a group of machines, but at least it's a single application. Overt, of course, you've got different components and different whatnot. If you ever, I tried to install Overt, and it installs like 1,001 other packages and configures SSH keys and does all sorts of, it looks complicated. And it didn't, the install process that I tried didn't work all the way through for some reason. A lot of these sorts of tools, they get quite complicated when you start to put them together. And then you've got the big boy, OpenStack. So OpenStack started off as a cooperation between Rackspace and NASA. Basically, they're trying to make a public cluster, open source version of a public cluster. So OpenStack doesn't directly compete with Overt. They're aiming for different levels of a similar sort of thing. So Overt might be your own personal cluster, whereas OpenStack might be a cluster of clusters, if you know what I mean. So OpenStack, you could configure it so as you had your EC2 instances over here, your Zen cluster over here, your Overt cluster over here, your KVM cluster over there, and it gives you an overall view of the whole thing. It's very much components all over the place. So Nova seems to be your main component. It does the compute type stuff, so handles your virtualized, your virtual hard disk volumes, your networking, your compute instances. So this I want this VM to run on this physical host. I wanted to have this much memory, this much CPU, and all that sort of thing. Swift is more for object store, similar to Amazon S3. So when you are dealing with cattle scale out type scenario, like we were saying, you don't want to have your information stored in on the virtual machine, because the virtual machine is a disposable throwaway commodity. So when you start to do that sort of thing, you start to deal with object stores, and Amazon S3 is basically an object store, Swift is an object store, and you're basically getting an object, either maybe an icon on a web page, or maybe a whole database from a URL that's stored somewhere else, and you don't care about that. It's not stored with a virtual machine, it's stored on some other cloud storage somewhere, and where it is, you don't really worry about. If the virtual machine moves, even if it moves to the other side of the world, it should still be able to get that same object using the same method with the same link. So Horizon is the web interface side of OpenStack. Again, it has the APIs that you can call rather than to manually go to the website yourself. It also has an Amazon EC2 style API if you have tools to deal with Amazon. The Keystone is for the authentication and security and making sure you have authority to act on that virtual machine or not, or you could effectively have it so as this group of people can have access to this virtual machine, but that group of people are in charge of that group of virtual machine, and all that sort of thing. And then you have your nodes. So OpenStack can deal with VM images, VM virtual machines, different hypervisor, bare metal, an Overt cluster. It's all plugin based, and it's all different modules for different things, and it's all a constantly moving target, which I think is what makes it so difficult to actually implement. then you got your, so before I was talking about guest tools and para-virtualization. So Red Hat were nice enough to develop VirtIO, and there are VirtIO drivers for Windows. So that means that if you're using VirtIO, you can pretty much, when I changed my virtual hard disk from a standard hard disk image to being a VirtIO interface, the Windows machine ran so much faster, it was well worth the effort. It increases the speed quite dramatically. The networking, I didn't notice too much difference in the speed of the networking, but I'm not heavily loading my network, so that's probably why. If you're using VirtIO, you have a VirtIO graphical driver, and that's designed to work well with Spice, which is the newer replacement to VNC. And there is also a VirtIO serial. The VirtIO serial is mainly for communication between the virtual host and the virtual guest. So if you've got your guest tools inside your virtual guest, the VirtIO is a mechanism for the host to be able to talk to that virtual guest tools. This allows for things such as copy and paste between your physical host and your virtual machine. Of course, if you're doing a VNC, if you're doing a remote desktop into the Windows, you still got your normal sort of copy and paste that you would get with doing a remote desktop to any Windows machine. So it's sort of like not necessarily a big advantage, at least not until, it's not a big advantage once you have your Windows up and running and you can remote desktop to it and whatnot, because then you can come through to the Windows through other means and you don't have to worry about this sort of stuff. But it does offer you, the other thing that the guest tools do offer you is the ballooning. How many people here know what the virtual machine ballooning is?
I think when they run out of memory and start using the hard disk.
Basically, the virtual guest, the guest tools inside the virtual machine, when the physical host wants to claim back memory, the guest tools will run this balloon process. And this balloon process does basically nothing but take all the memory it can and then release all that memory. So if you've got, say, for instance, I know you've got SQL Server running on that Windows machine, and SQL Server tends to grab as much memory as it can because it's more efficient. So now your physical host wants this memory back, or at least some of that memory back, in order to give it to another virtual machine or to do whatever it wants to do. So it will send a message to the guest tools, and the guest tools will start this balloon process. This balloon process will ask Windows in that guest machine for a whole bunch of memory. And so Windows will sort of say, well, SQL Server, you don't need all that memory, you scale back. So SQL Server will release some of that memory, maybe it'll release some of the cache data and things like that. And then that balloon process will have that memory, and then it'll just release it back. So effectively, you're cleaning out the RAM from within the virtual machine. I have had a virtual machine, this was actually on VMware. I have had a virtual machine that looked to be behaving itself, but was not performing properly. And when I went looking into the virtual machine, trying to figure out what was going on, I noticed the VMware balloon process was running, and it was running all the time. So what was actually happening was that the physical machine that this virtual machine was running on was running out of RAM. And it was telling the guest, give me back the RAM. Through this balloon process, it was trying to get the RAM back from the guest. And they would then give it to the other virtual machine, and it would run out of RAM again. And so basically, it was in a situation where it was constantly taking RAM back from the guest, and then that guest would take the RAM back from the host and take the RAM. And basically it was running. CPU levels within the virtual machine were quite normal. I think the weight might have been quite high. If you look at the top, you've got this weight level. So that was quite high. But other than that, it looked like it was running fine, but it just wasn't performing. And the reason is that there was not fit enough memory resources on that physical machine. And then we found out that the provider that we were using had actually moved the virtual machine around, and it was actually running on a lower performing virtual machine with another heavy virtual machine. So running on a lower performing physical host with another virtual machine. So look for that virtual ballooning process. I forget what VMware calls it, but I'm sure if you Google search it, you would find it. The other thing that the guest tools allows you to do is when you resize your SPICE view of the console, it will actually resize the desktop. So rather than having to scale the image or having a window like this and having to scroll down and scroll the whole desktop around in order to see the whole desktop, the guest tool will actually tell Windows, change the desktop size to fit this window nice and neatly. And that's basically it. Is there any questions?
Yes, is the guest tools also responsible for passing USB devices?
Sorry?
Yeah.
I don't think it is, because I've done, the impression I have is that was around long before the VirtIO was around. And USB is a hot pluggable hardware. So I don't think it would require a guest tool to be able to do that. What it'd have to do is, sorry?
I've worked with the one you're talking about, but in VirtualBox, sometimes you have to assign resources for USB, I guess. Yeah, I've done a lot of it myself. So,
but did you need to have the guest tools running within the guest for you to do that? Because I don't think you did.
For USB 3.
Yes, sessions.
Okay.
I think so.
Yes, sessions. I don't know nothing yet. So,
Because USB is designed to be a hot pluggable hardware. So, if the OS is expecting USB to come and go, it shouldn't need a special.
But the host part of the guest.
Well, the operating system within the guest.
USB through the host to the actual guest session.
Yeah. So, but the operating system within the guest would have to be able to expect a USB device to come and go, depending on whether someone plugged it in or plugged it out. So, if you wanted your physical machine to your physical hypervisor to pass that through, all it would have to do is pipe the information through and make the hardware, because it's controlling the virtual hardware, and make the virtual hardware to pretend to be that USB port.
I think some of them are a bit more clunky. I think some, like the Oracle ones, they do it on the fly. Well, I think KVM, whatever, sometimes you got to restart.
Yeah, I have seen that you can put plug-in CD-ROM images on the fly. If your operating system can handle it, I've seen some virtualization tools that will allow you to add more memory on the fly. I've heard that you can actually, when you get to the really big, high-end sort of hardware, they will actually allow you to hot swap a CPU, which is quite astounding. So,
and the other big thing is what the PCI pass-through now, so you can have access to your graphic cards through the virtual guest directly to get like OpenGL working and all that sort of stuff. That's quite interesting as well.
Yeah.
I don't know much about it, but I've been hearing that.
I don't know much about it either.
They're working on it.
Yeah, it's actually quite good. It's a big pain to set up, but it's very cool. You can have like your Windows guest use a second GPU, and then you can play games within that. Whereas if you use the more traditional, like virtualization type thing, it's too slow.
It's 96% of the efficient.
Yeah.
I've also heard that a lot of virtual machines, a lot of virtualization hypervisors these days will actually do memory deduplication. So if you've got two virtual machines and they're both running Windows XP, or probably not Windows XP these days, let's say Windows 8, then a lot of the memory inside those virtual machines is basically identical. The Windows kernel is probably sitting in the same location in both those virtual machines. So the hypervisor will actually deduplicate that memory in order to...
Doesn't that take memory to do that?
I think it does it in a sort of a copy on write type scenario. It would have to. So it would have to realize first that the memory is identical, which means it would have to be sure of it. So it probably has to do some sort of checksum on that block of memory in order to be sure. And a checksum's not... there is a chance that a check two blocks of data could have the same checksum and actually physically be different. It's extremely unlikely, but it's possible. Sorry? Yeah, it's like you maybe have only one chance in a billion, but it's still possible for two blocks of memory to be identical and to be different and have the same. So how much do you trust the checksum? If the checksum checks out and that block of data appears to be the same, you probably still want to go through and check it yourself, byte for byte. So first it would have to realize that those two blocks of memory are the same. Then it would have to map them across to the same copy of that data. And then it would have to watch what was happening to that block of memory, because if anything wrote to that block of memory, if, say, virtual machine A wrote to that block of memory, it would have to then, virtual machine A is actually written to there, so it needs its own copy. Spawn off another copy, give that to virtual machine A, and then continue to have virtual machine B, C, D use that central copy.
Yeah, but what I'm saying is, I'm pretty sure, I know with data deduplication, it tends to be a very RAM-intensive process. So you have for virtual machines where, especially if you're running the same instance of something over and over again, instead of like wasting your hard drive space to have data deduplication seems to make a lot of sense.
Yeah, I think that would probably have to.
Different in the sense that you can't assume that they'll be block a line.
Yeah, they may not be in the same block of memory either, yes. What I would guess, and I don't know too much about how it works internally, but what I would guess is that they would have to make an educated guess based on what is in that memory. In most operating systems these days, you flag certain things about the block of memory. For instance, if you have your software loaded into this block of memory, that memory block is labeled as being executable code. Executable code is probably unlikely to change, or much less likely to change than data. So you'd probably be safer to do a deduplication on that rather than what is a normal memory block. Maybe they found shortcuts in how to do that and some educated guesses, but I have heard that both VMware and KVM do memory deduplication on the fly on a live virtual machine, which I find quite astounding that anybody would even attempt that.
You didn't really speak much about containers. I noticed that containers are kind of a big rave at the moment.
Yeah, they're much more efficient than a virtual machine. I have given a talk on Docker before here, middle of last year or something. It's probably still on YouTube somewhere. I've played around with it a fair bit. It's not a new concept. I think the reason why it's such a big thing these days is because Docker has sort of standardized the way that the images are built and imported and controlled and made it simple. So every Docker image has what is effectively like a git commit type key. So you know that Docker image is correct up until that point. and then any changes that get stored get changed into a different Docker commit type thing. So it has a lot of things in common with the Git commit type scenario. You make your change, you commit it, and that commit becomes another commit string, and that's your Docker image. So if you've got the string there, you know that it's identical to another image that's using the same string. You can actually go and see the history of a Docker image, and you can see that this is what was done here. This is my common base, and then from there I did this, and it created this this image, and then from there I added this extra commands, and it created this image. You can see the history of it. It is dramatically faster. It's pretty much native speed.
What about security? Like, is it possible for, and this goes for VMs in general, the guest, because I was reading the Red Hat security blog, they were talking about some kind of vulnerability where a guest was compromised and he was able to compromise the host somehow.
In theory, it's not possible, but people have managed to do it. In theory, it's not possible. What's in the guest stays in the guest, but people have managed to do it. Don't forget, you've got these guest tools that are obviously able to talk. So if there's some sort of fault or security hole in those guest tools communication, then a hacker might take advantage of that to do something on the host. The one I find even more astounding, because a virtual machine is supposed to be completely isolated. It can't see anything. But there have been cases where people who are running on the same CPU as another virtual machine guest have managed to figure out things and information about what's running in that other guest, simply based on how long it takes them to process something, or I don't really know how, but there have been cases where people have arranged to have their virtual machine running on the same physical host as another virtual machine, and then use various techniques well and truly above my knowledge, and well and truly involving a lot of math and crunching and guesswork and all that sort of thing, to figure out encryption keys and things like that from the other guest machine.
This is also thinking, like, when you, I think it's chroot, you chroot your file system to kind of isolate it. Is it contained? I'm assuming it contained does something much more sophisticated than that. But
chroot is the very so the whole point of a container is that you're isolating the process. How much isolation you get and how well it does it really depends on the underlying kernel operating system. So in recent years, there's a lot of things that they added to the Linux kernel to do this sort of thing. This is not new technology, like I said. Solaris was doing zones, which is pretty much the same thing 10, 15, 20 years ago. It's not new. And a lot of the older systems were designed from the beginning to be to do that. That's how their whole operating system worked. They added a lot of this Linux container type mechanisms into the Linux kernel already quite a few years ago. All the Docker's really done is made it simple to use for the end user. They're still adding more features to the Linux container mechanisms. So one of the big weaknesses in Docker at the moment is that it doesn't, you can't change the user inside the container. If you got your guest operating, your physical host here, and you're trying to run, say, for instance, MySQL, right, inside this container. Now, MySQL obviously needs to have access to the files inside that container. It needs to run as a particular user So maybe you can get that MySQL container to run MySQL process inside that container as MySQL. But then that process inside the container is running with the MySQL user is the same MySQL user that's on the physical host. And if he can break out of the container, he has the same access as that MySQL on the physical host. All right? This is the big security limitation in Docker at the moment. But there's new features coming to Linux kernel that allow for user name spacing as well. So then you could have the MySQL user inside the container map to a MyContainer MySQL user on the outside the container. So now suddenly, if he manages to break out of the container, he's only this container, MyContainer SQL user on the outside the container, which obviously doesn't have access to the MySQL process running on the outside the container. So it greatly increases the security mechanisms. But that's still just sort of coming to existence now. So that's probably the biggest security hole in Docker containers. Once they get that fixed, it will be much more secure. But certainly when they released Docker containers, they never claimed it was something that you could allow a non-trusted user to use. It was designed to be something that you could isolate a process, isolate an application, have multiple applications, multiple copies of MySQL running on the same machine, not clash. Those are the big advantages. It was never claimed to be that I could give you a container with MySQL and I know that you're not going to muck around with my copy of MySQL on the outside the container. It was never claimed to be that. In some day, I could see it getting to that stage, but I wouldn't say it's there yet.
With you had the Hawkins home, the office and home, I think it was.
Yeah.
I'm now thinking about like endpoints. There's an OS called Cubes OS.
Yeah, I've heard a little bit about it.
Yeah, where basically I think they basically run applications there's different VMs in the OS, and they're running like you run your web browser in one. So if you get infected with crypto ransomware, it doesn't encrypt your entire drive; it just destroys that VM, and then you just will boot a new one up, basically.
Yeah.
What else can they use for, like, in terms of homes? Because that's the only thing I thought about. If you could use it on it.
Well, it's very useful if you're trying things out. If I'm trying, say for instance, I'm doing a computer course, and in that computer course they're talking about setting up an Apache server with a backend database and networked across to this, and you want to try to implement this with separate machines, but you only got one physical machine at home, so virtualize it. I virtualize a copy of CentOS. I virtualize a copy of Ubuntu, and I can play around with those virtualized guests without any worry about breaking my my host machine. So I can, I'm free to do what I want.
Build a network inside them.
Sorry.
You can even build like a network inside your host.
Yeah.
Basically like that, like with that.
Yeah. So it's, with the, you can basically set your virtual machines to be on a tap device. So, and then you can network them together between those, between the virtual machines, and never have that traffic leave your physical host.
In VirtualBox, I don't know if you know that there's like there's 3 different modes you can have. You can have blind, or you can have half open side. So the machine can see outside of onto the WAN, it can see inside between 2 machines, or it can see between the 2 machines and the actual host. Is that similar to this, or?
Well, this is mainly a view of all sorts of different tools.
Okay.
Virt Manager certainly allows for a whole mess, a whole range of ways of doing the networking. And you can control it pretty much as you please. But it's really up to you. There's a whole, the networking in virtual machines is a talk in itself if you wanted to get into that level of detail. I think that for me, the best way would be just a routed. So NAT doesn't allow you to get traffic back into your virtual machine, of course. But if instead of saying NAT, I'm just going to do the same sort of thing. So with NAT, you have your tap devices that you create, and each virtual machine is connected to that tap device. And that tap device to your physical machine looks like a network adapter.
Yeah.
And then you can basically decide, okay, I'm going to give this network adapter this IP, this subnet, etc. And I'm going to route it across to this one, etc. So when you're doing NAT, it's doing that, and it's giving those virtual machines IP addresses like 192.168, whatever. And your NAT's basically converting that into the external IP address on your physical machine.
Yeah.
But of course, that doesn't allow for traffic coming back in. What I would do is leave those network devices there, don't use NAT, but I'm going to give it an IP address that's also accessible on my outside network. And then there's an option in the Linux kernel to say forward IP. So then I would say for instance, my overall network is 10.10.10.10, or 10.10.10.0. And all the virtual machines that I have, I've given it the IP range 10.10.10.11, right? Or 10.10.11.0, right? So then I can just basically say that tell my Linux kernel on the physical machine to forward IP, and I just basically, for any other machine out in the wider network, I just say, if you're looking for 10.10.11.0 or 10.10.11. anything, send it to this physical machine. This physical machine will receive it, and it says, oh, well, I've got all these other networks, all these other network adapters that are all virtual machines that have that address, and just hand it off to wherever it needs to go.
But when you hit ifconfig, does it actually show different virtual?
Yeah.
Yeah, it does that in that shows.
And I'm not sure if I still got something here, but so I installed I'm used to having a KDE desktop, and I installed Ubuntu Basic, and they do things quite differently.
Is this the new one that just came out?
Yeah. So you see here, you got the virtual bridge and virtual bridge. And if I go and do so I've got this network. Yep. So this is just a virtual machine of Windows. And if I do again, I think we'll find net zero. So to the base operating system, this is just another network adapter. At some point, this machine is going to get an IP address. Now, I'm not sure what I set up on this. I just fired this virtual machine up just a minute ago, so I'm not sure what. So I've given it NAT style.
That's the Red Hat driver.
Yeah. It's going to not find it, I don't think. I did have those images set up to use the VirtIO driver, but I forgot to set it when I attached it to a virtual machine. So it had the the older style, pretend to be a normal IDE hard disk. And Windows, when you don't, if you have the VirtIO driver set up in Windows, and then you give it a normal IDE hard disk, it throws away the driver for the VirtIO. And you have to go through the rigmarole to install it again. It's really quite annoying. So let's see what we've got here for IP address. I think we should have something here. We might not, because I think the hard disk, the network card, I also yeah, 192. Yep. So you can see here it's got 192.168.22, 150 blah.
I think that's just to make sure that it's never sort of using that.
If I go to my physical machine now, so here's the let's see if we can get this side by side a little bit. So you can see here, this virtual machine is using gateway 192.168.122.1, and you'll see here this bridge device is that default router, default gateway. Now, this VNet, it sees, I'm pretty sure that's going to be this machine, but I don't think it'll be able to see the IP address inside Windows because that's inside the guest. The IP is assigned inside the guest, which the physical host can't get to. But yeah.
Is there any way of knowing that you actually need a VNet?
I think there's actually a tool that will tell you.
Okay.
That there are ways to know.
Oh, you can just check if you're running guest.
Well, if you're running guest para virtualized drivers, also if you
But couldn't you be in a scenario where it looks exactly the same as a
well, you know how when your machine goes and gets the BIOS information,
yeah.
If you get the BIOS information from inside a virtual guest, it comes back and says Red Hat virtual machine.
Yeah,
I think you can also, on the MAC address, you will have the vendor specific. So if it's VMware, you will have the VMware.
Yeah, yeah. So there's a lot of tools that will get the hardware information, the serial number, the BIOS, and all that sort of thing. And if you're inside a guest and you run such tools, you get things such as my BIOS is a Red Hat BIOS. Well, it's pretty obvious it's not really a Red Hat machine because Red Hat don't make physical hardware. So,
you have to work pretty hard to hide if that's what your intention was.
It's not. Yeah. I don't think their intention is to try to hide it.
I think if you can run a hypervisor and try to install another virtual machine, whether it works or not. I don't think.
Yeah, you can.
You can?
Yeah, you can keep going. It's inception.
Really?
Yeah.
You can.
Never tried that.
Not something I would recommend, but you can.
Eventually, you run out of resources.
Yeah, I think also it would depend on what type of CPU you're virtualizing too, because remember how the older style Type 1 virtualizer hypervisor would have to change the machine code on the fly because the CPU would only allow the operating system to run things in ring 0. And the guest is thinking it's the operating system. It wants to run things in ring 0. So it has to change the code on the fly to get that not to run in ring 0 and pretend that it's ring 0 to the guest operating system. Modern CPUs have features that deliberately allow for doing this sort of thing. So you have ring 0 on the physical machine and you have a virtualized ring 0 for guests, or something like that anyway.
But you can turn that off in the BIOS.
You can turn off that off in the BIOS, but KVM won't run without it. A lot of the modern virtualized tools won't run without it because the modern virtualized tools leverage that. It's much more efficient to do that than it is to try to do this convert code on the fly and
So that convert code on the fly. So the Type 1 bare metal hypervisors. So those are the things that use those hardware. But examples of tools that are used today. Would VirtualBox be one of those? VirtualBox is not.
I think all of them take advantage of the CPU code features if they're there. But VMware was around before that was a thing, so I'm not sure if it'll be able to go back to the old style, but certainly older versions of VMware were able to do the old style. It all gets kind of messy.
Modern hardware optimized for VM.
Yeah, if it's all modern CPUs for the last, when did they come out? Probably about 6-7 years ago. Maybe even the Celerons less than 6 years old is going to have, the virtualized features, and you're not going to need this type 1 stuff. It's, it's obsolete basically. It's slow. It's slower. So why would you use it when your CPU offers you a better option?
My processor is 10 years old and it has it.
Sorry?
My processor is 10 years old and it has it.
Yeah. Any other questions, or you want to see something?
When you were on the slide where you were talking about the snapshots,
Yeah.
sorry, there were another type where you said that you keep the original image.
The base image?
Only,
Yeah. So if you do something like, let me just go here. I'll exit out of this. Lib. That's images. See if I can type properly. So, because the hard disk partitions are not such that I could fit my virtual machine image in the actual root partition where it expects to see it, my disk image is actually a link to somewhere else, but it shouldn't make any difference to the. If I do QEMU image info and say for instance I go here, so you can see here. Can you read that at all?
Yeah,
I bumped the font.
Sorry.
Bumped the font. Control plus.
I don't think that works in GNOME Shell. It does. Okay, good. I know it works in the KDE's console, but I didn't realize it worked in GNOME Shell. So you can see here that it's a 2 gig image. It's taken up 2 gig of hard disk space. It's an 8 gig image. This is the name of the image, etc. Now I need to try to remember what the command line is. Hold on a second. Let me get out of this.
Have you done it recently?
I got it in my notes. Nope, don't seem to have it. I don't seem to have it in my notes here, and it's not going to be that easy to find. Basically, you would do something like, this is not going to be syntactically correct, but you would do something like create qcal2, and then you would say this is my base file, and my new file is new.qcal. And size, I wouldn't give it a size, something like that. It'd be something like that, but I'm not sure enough of the syntax to know if this is going to work.
So everything that changes on the disk from that point is going to be created on the
So
on the new.
Did I do it? Yes, it did. Well, I guess the format properly, the kind of syntax properly. So if I do a QEMU image info on this new file, you'll see backing file.
Okay.
So that means that that original image, the base XP general QCal image, is a read-only image. Anything new that gets written to this, so you would mount this new image in your virtual machine or whatever. Anything that gets written to this new image will be written to this file, but anything that is read will be read from both this new file and the original file. So wherever the new file has a newer information, it will read that new information. Wherever it doesn't have new information, it'll read from the original file.
And can you create two of them and then mount it on?
Yeah, if I create a second one and say this time call it new2, right? You'll see here now that I've got both of them.
Yeah.
I can mount both those to separate virtual machines and they'll be quite happy because anything that's written to them will be written to their own individual. So if I make one machine with the new.qcal file and one virtual machine with new2.qcal file, so I've got two virtual machines, one using each file. Whatever they write will be written to their individual file, and the common will be common. So you can see the size difference. So if I do ls minus lh, I'm not going to be able to do LH. So you can see the original file is 2.1 gig, which is quite compact for a Windows XP install. But it's 2.1 gig, whereas the new file, 193K. Of course, once you start running a window, once you boot that virtual machine, it's going to grow larger than that because Windows is always writing stuff to the hard disk.
And if you format the disks, it's not going to affect the original one.
If I format the new one,
The
new one, yeah, it's not going to affect the original one because anything written is only written to the new one. But if I formatted it, it would lose the advantage of having that base image because the new image would then have all the information of every track on the hard disk, right? And it wouldn't be going back to the original base file for anything because you're just told everything's here, everything's rewritten from scratch. So you'd lose the advantage. But yeah.
So how do you mount this new file to your virtual machine?
No, we could, if I go to Virt Manager,
So if you take snapshot, it's just become bigger files?
Yeah, snapshots basically like this, like the base image type thing, but it's doing it within the file. So the idea is if I made a snapshot of that file, of that image, it will say from this point on, all new writes are written over here within the same file. And if I ever say, okay, I want to go back to that snapshot, it'll throw out all that save and come back to that no one state.
Save game.
It's safe. Yeah. So if I then went and did,
the guest, like you can't mount snapshots or it's specified for that VM, whether using that backup, was it backup disk, you can mount it to different VMs. Like you
Yes.
can't mount the snapshot. Snapshot is for
No,
the guest, and
but
then
that backup one has one common file, and you can have multiple images pointing to that common file. A snapshot is within that same file. So you couldn't mount it to multiple machines because it's, if, for example, I had this image and I took a snapshot and I mounted the snapshot into this virtual machine, and then the non-snapshot version of it to this virtual machine, then anything this machine writes will be on its own, will be isolated from that other virtual machine. But anything this virtual machine writes is going to be written to the common component between those two virtual machines. Two operating systems right into the same hard disk, it's not going to work very well. Something's going to go wrong. Yeah.
Okay, if you have the same setup, you set it up using VirtualBox, the same sort of size and everything, and with this KVM setup, because it's local, native, would you see a speed in the...
VirtualBox uses its own virtualizer, its own hypervisor, right? KVM's the hypervisor built into Linux. VirtualBox and VMware, they use their own hypervisor. VMware is actually a bit of a bastard to use on Linux because it needs its own hypervisor driver built into the Linux kernel, right? And with every version, every new Linux kernel, you have to recompile that driver. So every time you update your Linux kernel, you can't be certain that VMware is going to work because you need to recompile the VMware driver that allows it to do its virtualization, because it doesn't use the Linux kernel virtualization that's built into the Linux kernel. It uses its own.
So you would say that the performance of the guest would be faster if I use KVM compared to
They're about the same, but I have heard that VMware stopped publishing their performance benchmarks of their virtualization when KVM's benchmark started to be better. I don't know how true that is, but that's what I heard.
That site phonorinks or whatever, I didn't have the answer, just read it. They did one where KVM and Zen were the top two, and KVM was just marginally better than Zen.
Yeah, Zen is also a separate kernel module. So again, every time you update your Linux kernel, you have to go and recompile Zen or muck around with Zen and get it working again. So that's why, I think that's why KVM is more popular, because I don't have to do anything. It's in the kernel. I don't have to do anything. VMware does have their own bare metal hypervisor. They call it ESX. I think it's called ESX. Yeah. So that's basically the VMware that you run within Linux or within Windows sits on top of Linux or on top of Windows, right? But ESX is an operating system in itself. It just does the virtualization. So its performance will be much better than VMware under Windows, because you don't have that. The underlying operating system is cut down to the bare, just enough to run the virtualization.
Like that for Linux?
KVM is that for Linux. So if you wanted to do, because KVM is built quite deeply into the kernel, it's pretty much the same thing.
Yeah, bare minimum distro.
Yeah, if you wanted bare minimum distro and just run, it would pretty much be the same as ESX. I think that's why they stopped sort of publishing the benchmark, because I heard that they were pretty much on par with each other. So, yeah. All right. We usually go to the pub, Piedmont Bridge Hotel, if anybody wants to.
I think the presentation, like your slides are over.
Yeah, that was the last slide a while ago. Sorry. Yeah, so if you want to join us at the Piedmont Hotel, that would be good. We can continue conversation there. I think Tim would want us to leave soon. And thank you.